Unit 4, Lesson 8, Student Example number 1B. I'm looking for side X. If I take a look, I can see that side X and the length of this line right here are equal to each other, and I know that because of this dash. Another thing I know is that from the center of the circle to the edge of the circle is a radius. If I've told here that my radius is 8, this is also 8 because it's a radius as well. I'm going to say that this is also equal to x. Another thing I know is that the length of this entire line is 10. Where a radius and a chord meet at 90 degrees, we can say that that radius will bisect that chord. That means that it will cut it directly in half. Because of that, we know that this length and this length are equal to the same thing, each of them being half of 10. So each of them has a value of 5. We take a look at this triangle here. We can see that it's 90 degrees, and we have everything we need to use Pythagoras theorem to figure for the missing side. Let's say that our side opposite to our 90-degree angle is the hypotenuse, as usual. Let's say it's C again. All right, I'm going to say that this side, this 5 side, is my A, and instead of B, I'm going to use X. Writing out Pythagorean theorem, C squared equals A squared plus B squared. C had a value of 8. A, I said, had a value of 5. And B, we're going to use X instead. 8 squared is 64. 5 squared is 25, and I don't know x, so I'm just going to rewrite it. In order to isolate x, I need to subtract 25 from both sides. If I do that, I will see that 64 minus 25 is 39. I want x, not x squared, so I'm going to take the square root of both sides. Square root and squared will cancel, leaving me with x equals the square root of 39. The square root of 39 has a value of 6.2.